Today we are going to discuss one of the questions that was asked in JEE mains of the previous year. So the question is saying that a small rigid spherical ball of mass m is dropped in a long vertical container containing glycerin. The velocity of ball becomes constant after some time. If the density of glycerin is half of the density of the ball, then the viscous force acting on the ball will be. So here we have been given that there is a beaker in which there is glycerin, and in it ball is dropped, and after some time the ball is traveling with a constant velocity in the downward direction, that is in the direction of gravity. So we have to find out what would be the buoyant force. Here the given information is the density of glycerin is half of that of the density of the ball. So we know that when a body is traveling with a constant speed, a constant velocity, that means the net force acting in that direction is going to be equal to 0. So here we can say that net force in the y direction is equals to 0. Now let's list out the forces that are acting in the y direction. First is gravitational force that is acting in the downward direction with the magnitude of mg, and the second is buoyant force which is acting in the upward direction, and its magnitude can be given by the density of fluid times volume of the ball multiplied by the acceleration due to gravity, because we know that the magnitude of buoyant force is equals to the weight of displaced fluid. Now the unknown force is viscous force, which acts in the opposite direction of the motion. So here when the ball is moving downwards, it will act upwards. Now let us equate these forces. We can say that force of gravitational force, the gravitational force is equals to buoyant force plus viscous force. Now equating the magnitudes, we can see that mg is equals to rho of fluid, that is the density of fluid, times the mass of ball divided by rho of ball. Here we are finding, with this expression we are finding the volume of ball, so that we can calculate what would be the mass of fluid, and then we will multiply it with g to get the weight of the fluid displaced plus the viscous force. Now we know the relation which is given in the question, that the density of fluid is equals to half of density of the ball. So we can substitute this in the above expression. We will get mg equals f, that is the rho of ball, that is the density of ball, divided by 2 multiplied by mass of ball divided by density of ball multiplied by g plus viscous force. Now here we get viscous force is equals to mg by 2, that is half of the weight of ball. So this option is going to be correct. Option B is going to be correct for this question. Thank you.